like Apostolo said, my name is Michael Servos, and I serve as the energy manager of Tsakos Columbia Ship Management. Thank you for the invitation, and thank you for your time. What I'm going to talk to you about is about big data and Hallen Propeller Performance. Actually, Hallen Propeller is my main task on everyday routine in my job. I'm not an expert on big data, but I have to use them in order to get the results that I want. Allow me to begin my presentation with a smart example, a short story, which is, in my personal opinion, clearly depicts what is the issue with the big data. Back in late 80s in UK, there was a TV series which was called The Hitchhiker's Guide to the Galaxy. It was about an alien nation which they decided to build a supercomputer, which was called Deep Thought, in order to give them the answer to the absolute question, which was about life, the universe, and everything. So this supercomputer, after 7.5 million of years, they finally came up with a figure. And that figure was 42. Everybody was surprised. They got angry. Well, what is that? What is all this about? And then this Deep Thought, they told them that now they have to build another computer, which should be from organic material and at the size of a small planet, so they can have the real absolute question. Actually, this planet was Earth. But this is a good example of, it's not about the data. You need to make the right questions in order to have the right answers. So I was trying through the internet to find a definition for smart data. And one of the definitions that I came across reads, big data is a broad term for datasets so large or complex that traditional data processing applications are inadequate. Challenges include analysis, capture data, curation, research, sharing, storage, transfer, visualization, querying, and information privacy. The term often refers simply to the use of predictive analytics or certain other advanced methods to extract value from data, and seldom to a particular size of datasets. Accuracy in big data may lead to more confident decision-making, and better decisions can result in greater operational efficiency, cost reduction, and reduced risk. The key word is may. If you go this way, it's not money in the bank that you will get all the answers. You need, before you go towards this direction, you need to make some questions. And you need to answer this kind of questions in order to make sure that you know what are you dealing with. The first question is, what do I want to know? Does it worth it? Who will analyze the data? What are the sources of data? And, like the other gentleman said, what about data and cybersecurity? We are a ship management company, so we focus on operational issues. We try to focus on measures that will help us to improve the energy efficiency of our operations. If we were a company that we had a new building department, our approach will be totally different. But now I will focus on the operational side. Before you focus somewhere, you need to do some kind of a risk assessment. You need to know where is the benefit in order to know and be able to identify the resources to spend in order to improve. And you want to know how much I can improve in each area. What we're doing, first of all, this is an example of a tanker with steam cargo pumps and business as usual for an existing ship. This kind of risk assessments could be different for different type of vessels. I'm just showing you this one. So we're talking about ship assets, port operations, and anchorage. And we have 5 big areas. You have the voyage planning, execution and propulsion, you have the electricity production, you have the steam production, you have the incineration, okay, but it's minimal, but still you have to put it there. I have to say that this kind of risk assessment is in line with the requirements of 50001 ISO on energy management systems. We are certified towards this ISO, so we need to make this kind of assessment. So having done our homework, we came up with a scenario that if everything turns bad, if everything goes the worst way, then that might lead to a 40% increase in our consumption, even for the first year. By doing a decomposition of this percentage, we identified that the most significant area, of course, is sea passage. And drilling further down, the most significant part is hull and propeller efficiency. So it makes sense for us to start from there. Our first, like I said before, our first priority was to quantify hull and propeller performance. Only through the quantification, we could have a clear picture of the efficiency of our dry dock strategy. By the term dry dock strategy, we mean hull treatment, the coating selection, and the application. Furthermore, it is a tool that allows us to timely identify the need for a hull cleaning or even make predictions, which is very important as well. There are various methods that can be used or even combined to derive conclusions on hull and propeller, but the most important parameter, as always, is the resulting accuracy. You need to go down and ask yourself, what is the accuracy of what is being presented to me? And here, from step one, you need to increase your accuracy, and there is where the big data comes into the picture. With the use of telemetry, nowadays, we have real-time access to any kind of information that we need from a vessel, provided always that the vessel is adequately equipped. And this high-frequency information collected from the vessel, combined with information from other sources, weather, for example, it can be used so we can increase the level of accuracy, and that would lead to a more confident decision-making. And according to the definition of the big data, better decisions can result in greater operational efficiency, cost reduction, and reduced risk. Like you see here, in the step one, you see the development of added resistance or power within time for a vessel. There are many approaches. You can do that with noon data, you can do it with dedicated sea trials, you can do it wherever you want to put it there. Input you have from the vessel, you can somehow build this. But the issue is the accuracy. The accuracy of the first graph that you see could be something like 3% or 4%, though. So when you read 20, that could be 23, or it can be 17. And this is a big gap. In order to close the gap, you need to go to telemetry and go to the step two, where your accuracy could be less than 1%. When you see a 20, you know it's 20. It could be 19 or it could be 21. So you have the real input that you need. So following the step two, we go to step three, which is goal setting. One of the tools that we're using is based on the graph depicted in the top right corner. Our goal is to have what you see there. Let me explain. You have on the x-axis, you have the dry dock performance, and you have on the y-axis the underwater maintenance savings. So what we're trying to do is to have the highest possible dry dock performance, and at the same time that will result in the minimum underwater maintenance savings. It makes sense. The better job that you do in the dry dock, the less cost, the less output you will have for the 5 years of the vessel that will be at the sea. So our goal is to reduce the savings that we have from the underwater maintenance. We want to go for the highest benefits from the dry dock. There are various reasons that we have to do that. One of these is environmental, because hull cleaning is getting banned in more and more countries. There is an impact because you have debris for the hull cleaning. You need somehow to deal with that. And also, every time that you send a vendor, a diver, to clean your vessel, you increase the risk of damaging the coating and resulting actually in the opposite direction, the opposite outcome from that was initially requested. So As TCM, we managed, I did some calculations, and from the last dry dock cycle of each vessel that we managed to conserve more than 80,000 metric tons of CO2. This is an average figure. It's a not bad one, but our goal, like I said before, is to further reduce it. In order to do that, we invest in telemetry. We are developing in-house hull and propeller performance analysis modules. We are contributors to the ISO 19030, which has to do with measurements and changes in hull and propeller performance, and at the same time, we try to optimize our dry dock procedures. That was our experience on the subject issues, and thank you for listening to me.